This packet is going to be notes. It's also going to be the homework assignment. Okay? Sound good? Okay. Okay, so if we look at the first problem, we're going to be able to write mostly the intercept form from this a little bit. We're going to get pretty close to writing most of the intercept form. We're going to need a little bit more information to be able to completely write the intercept form. So if you look at this, what are the x-intercepts? 2 and 6. So if I write the x-intercepts, I would say the x-intercepts are 2, 0, and 6, 0. And so if we kind of work our way backwards and we put those into the factors, into the parentheses, what would have been these? -6 and -2. So I would have said like y equals x minus 2 and x minus 6. Okay? And what is the one thing that I said that you can see in all of the forms? The A. It's the A value. The A value is that coefficient you can see in all of the forms. So in this problem, we don't know if A is 1, which is what it normally is. We don't know if the value is 2. We can tell from the picture that the A is not negative because this graph is not upside down. But we don't know if it's 2, we don't know if it's 3, we don't know if it's 1 like normal, we don't know if it's like something else. But we do know that the x-intercepts are 2 and 6. We can tell that from the intercept form. Okay, so what we want to do to figure out A is we want to find some other point on the graph to plug in for x and y so that we can solve for A. So what's another point on the graph that is recognizable? The vertex. Okay. So I can see the vertex, it's right there. And then what is the vertex? 4, -4. Okay, so I'm going to write this over here. My vertex is +4, -4. Okay. So if my vertex is +4, -4, then what should I plug in for y? -4, so this is a y coordinate, so I'm going to plug -4 in for y. And what should I plug in for x? +4. So 4 minus 2, 4 minus 6. Okay. So 4 minus 2 is 2, and 4 minus 6, -2. Okay, what's 2 times -2? -4. Okay. So I have 2 times -2 is -4. -4 times A is -4A. So how do I get the A all by itself? Divide by -4. And so A equals 1. So if the A value equals 1, what does that mean for that transformation? Stretch? Is there a compression? Nothing. It's not a stretch, not a compression. This graph is normal. It doesn't do anything outside of what the normal parent function does. It's not tall and skinny, it's not short and fat, it's what the normal parent graph looks like. So for my intercept form, I'm going to write y equals x minus 2, x minus 6. Since the A value is 1, I don't even have to write a coefficient. You can put the 1 in the front if you want, but you don't have to, because 1 is normal. Okay. Now, we do know the vertex, so we can actually get started writing the vertex form, right? Our vertex is 4, -4, so we can start writing that. Y equals, and then I've got my parentheses squared. What should go inside my parentheses? -4, so we do the opposite of that number. And then on the end we put -4 because we do the same as the number on the end. So opposite of this number, the same as this number. So my vertex form is y equals x minus 4 squared minus 4, okay? And then we can use either the intercept form or the vertex form. It doesn't matter which one. Either of those forms can help get us to the standard form. Which one would you guys like to use? Intercept form, okay? So if we use the intercept form, what do we have to do to it to get to the standard form? We got to FOIL it out. We're going to FOIL it out. Okay, so I'm going to say y equals x minus 2, x minus 6. I'm going to FOIL it out. X times x is x squared. X times negative 6 is negative 6x. Negative 2 times x is negative 2x. Negative 2 times negative 6 is 12. So what does that give us when we combine like terms? Okay. All right, so we have all three forms. We are done. Okay, number 2 we're going to skip because number 2 is just like the problems that we did on Friday. They gave you the intercept form, so I think that we can work with that. That's not going to be a problem. I don't think number 3 is going to be the hardest problem we have, so we're going to skip that. Number 4, they gave you in standard form. You're converting it to the others. I think that one's fine. I want to look at one like number 5 where they give you a table. And then in number 6, when they say by completing the square, real quick, just rewrite it in vertex form. Do not worry about the process of completing the square. You do this process by completing the square in Math 3. We've learned how to solve by completing the square, but we've not learned how to do it when it equals y and it doesn't equal a number. And the process is slightly different, and I don't want you guys to worry about that as a Math 2 concept. So I'm going to let you guys just do it using the negative b over 2a and not worry about using completing the square to do it. Okay, so when we do these using the table, the easiest way to use the table is to look for the vertex in the table and to look for the y-intercept in the table. So the vertex you can find in the table because you can look for symmetry. And the symmetry is saying that I know that these graphs are U-shaped. So somewhere there's going to be the middle of the U. You can see where the middle of the U is, and then you can see where it's going to have the Y values are going to start to repeat themselves. So can anyone find the middle of the U? Yeah, Peter. 2, 4. So how, somebody else explain how Peter knew that was the middle of the U. Yeah, Savannah. Yeah, so we can see the 5s and then the 8s, and then we assume after that that's where we would have the 13s. Okay, so 2, 4, here's our vertex because we're seeing the symmetry. Okay, somebody other than Peter or Savannah, can somebody other than those two find the y-intercept? Yeah, Jack. 0, 8. 0, 8 is the y-intercept. And how did Jack know that was the y-intercept? Yeah, Asa. Because the x-coordinate was 0. Okay. So let's go ahead and use this. Do you guys, which form do you guys think the vertex is going to be most helpful in? The vertex form. Okay, so let's go ahead and start writing the equation in the vertex form. So I'm just going to start writing y equals, and then what numbers could I start plugging in? Okay, so I'm going to write x minus 2 squared plus 4, okay? And then what else shows up in every single equation? The a value. So we want to be able to solve for the a value, okay? And then we know, I'm going to go up here, we know that the standard form is going to be y, I'm going to write this lightly because we're going to replace it, we're going to erase this and replace it. But we know the standard form is ax squared plus bx plus c. And what is that c value? What's the number on the end always? It's the y-intercept. So what number is that going to be? That's going to be 8. Okay. We can go ahead and make that 8 right now. Well, that's going to be 8. Okay. So we have our vertex. We have the vertexes 2, 4. And then what should we do with the other point we found, the 0, 8? We want to solve for a. We have an x coordinate and a y coordinate. We want to solve for our a. Plug it in for x and y. Okay, so what are we going to plug in for y? 8. All right, we're not going to plug anything in for a. What are we going to plug in for x? 0 minus 2 squared plus 4. Okay. Now, if you couldn't find the y-intercept on the table, that's fine. You could literally use any other point because all of the points have an x-coordinate and a y-coordinate. So any other point would be fine, okay? The benefit of using the y-intercept is that one of the coordinates is 0, and 0 is easy to work with. It's also kind of nice because it gave us the 8 on the end of this one. So that's kind of nice, okay? All right, so let's start to simplify. Whenever we simplify, we have to do order of operations. So since we are not solving an equation, we're not going to do order of operations backwards. We're going to do order of operations in the correct order. We're going to do parentheses first, then exponents, then multiplication and division, then addition and subtraction. So let's look inside the parentheses. What's inside the parentheses that we could simplify? 0 minus 2, which is just negative 2. Then we're going to do our exponents. So what is negative 2 squared? 4. So we have 8 equals a times 4 plus 4. All right. At this point, now that we've simplified this, now we are solving for a. Does that make sense? So now I am done with just getting my numbers worked out. Now I'm solving something, so now I can go through and do order of operations backwards. So now I'm going to see what I can add or subtract to the other side, then multiply or divide. So what could I add or subtract to move away from the a value? Subtract the 4. So I get 4 equals a times 4. And then I'm going to look to see what I could multiply or divide. Divide by 4. And so a equals 1. All right. So again, we have our a value being 1. That just means that there's no stretch, there's no compression. The graph is not upside down, it is right side up like normal. So our vertex form is y equals x minus 2 squared plus 4. All right, now to find the a and the b values, we already know the a value, right? We know that it's 1. Okay, so we have 2 options for the standard form. Well, do you guys want to put a 1 there, or do you want to just leave it blank? Just leave it? Okay, so we have x squared plus bx plus 8. We have two options for this other problem. So what we can do is we can take the vertex form and we can expand it out and put it in the standard form, or we can pick another x and y coordinate off the table and we can plug it in for x and y in the standard form and we can solve for b. What would you guys rather do? Plug in an x and y? Okay, so of all the points on the table, we got negative 220, negative 113, 1, 5, 3, 5, 4, 8. What do you guys want to try to plug in to solve for b? 4, 8? Okay, so we'll take the point 4, 8. And those of you who maybe don't want to plug in 4, 8, what you can do instead while we're doing that is you can take the x minus 2 squared plus 4, and you can write the x minus 2 twice and FOIL it and add 4, and you'll get the same answer we're about to get, okay? All right. So we're going to do the 4, 8. We're going to use 4 for x, 8 for y. And so we're going to plug 8 in for the y. For x, we're going to do 4 squared plus b times 4 plus c. So we're plugging a point in for x and y so that we can solve for the b value. All right, what should we do? What do you guys think? What should we do? Okay, we can subtract the 8 over. So those cancel, this zeroes out, so we get 0 equals 4 squared plus b times 4. What should we do now? We can't divide by 4 yet because we got that 4 squared just chilling right there. What's the 4 squared? 16. 0 equals 16 plus b times 4. So before we try to divide by anything, we have to have the variable on one side and the plain number on the other side. So what should we do with the 16? We're going to subtract it over. So negative 16 equals b times 4. And then what should we do? Divide by 4. So b equals negative 4. Okay, so if I go back up here, I'm going to erase my plus b, and I'm going to put minus 4x. Okay. Did anyone do the method where you FOIL? Did you guys get minus 4x plus 8? Okay. What method did you guys think was better, those of you who FOILed? The FOIL way you liked better? Okay. You think it's faster? Okay. So those people who FOILed said they would not recommend plugging a point in. They would recommend just FOILing it out. FOIL people said that. Okay. Cool. So you can see that for number 7, they said write the equation of a quadratic function in standard form. They gave the vertex and they gave the Y-intercept. So what they did is they basically are giving you enough information in number 7 to write the vertex form. Do you guys see that? Number 7 is kind of like number 5. But they gave you the information just writing it down instead of in a table. Do you guys see that? So in number 7, they're giving you the information to write the vertex form, and then you're going to have to do the FOILing out to write it in the standard form. So you're actually pretty ready right now to do number 7. It's what you just did. It's the work that you just did. All right, we got another table problem right here. They're going to make you fill out the table, though. says, for number 8, let's fill in the parts of the table they gave us. It says a y-intercept of 7. So what part of the table should I be filling in? So 0, 7, and a vertex of 2, 3. So under the 2, I should put a 3. Okay. All right. So then you're going to have to do a little bit more work. So what I'm going to do is I'm just going to give you guys some time to work on this. While you guys work on it, I'll work on an answer key as well, and then I'll be available to answer any questions you have. So not due till tomorrow, but the rest of this you are going to finish. Yes? No. No. Because I do not want you guys to take the answer keys out of the recycling bin because I do not want you to take them home. Okay? This teacher, I think, does things a little differently than we are doing them. Like, she's done completing the square to do some of these, and you guys are not used to that. So I will do these the way that we are used to doing them. All right, go ahead and get started.